Hello everyone and welcome to this video. I believe this is part 6, I think, of the series Raspberry Pi Pico, or getting started with the Raspberry Pi Pico. I got this kit, this was sent to me by a company called MicroPython, who to be honest are quite good value. I've looked on their website. Their parts are quite cheap. They do ship to the UK. I'll put a link in the description to this. Now you absolutely don't need to buy it, and you don't need to buy it through them. At the moment I don't have an affiliate link, so I'm completely neutral to it. However, you will need the components that are in it. Now you could build that up yourself, or you could just buy the kit, it's up to you. But this is a good kit nevertheless. So I've also got this book here, the official Raspberry Pi Pico guide, Get Started with MicroPython on Raspberry Pi Pico. And you may already be aware, because I've said it a few times, that this tutorial, or this series of tutorials, is based upon this book entirely, with my own things added on really, but generally speaking it's based on this. Okay, so if you've got the book, I'll be covering material from page 38 to say 43. Yeah, 43. So if you've got the book, there you go, 38 to 43. Okay, so time to get started. I'm going to open this kit up and we're looking for the breadboard. And there it is, just move this out of the way for now. So the breadboard, what's a breadboard? Right. The breadboard is a prototyping object which allows you to build circuits without having to solder them in place. So you could get components and just push them into the holes here, and this replaces wires and PCBs. So for example, if I was to get the Pico, where is it? You see the pins there? They fit perfectly into the holes. I don't know if you can see that. That's not a good example, just pull it back a bit there. Like that. Now if I was to push it in, which I will do slightly, they sort of jam into the holes, and then you can wire other stuff next to it. So just pull it back out and I'll just show you how this thing works. So the way it works is that you have rows and columns, and the rows, to be honest, are more important than the columns, because the rows are one piece of metal. So you see there where it says row 1, all of row 1 up to E is one piece of metal. So anything that you connect in there is all joined together. And the same for F to J in row 1, anything in that row from F to J is all together. So if I was to plug one wire in F and one wire in J, those two will be shorted together or connected. Yeah, and that goes down all the way throughout all of the rows. So row 64 here, again row 64 A to E is connected, and row 64 F to J is connected. Likewise on this side, if we just rotate it, everything on the red bar is joined together and everything on the blue bar is joined together. Now there is something that you've got to be careful of. Some of the breadboards are split there. So, there's a split in the red and the blue lines. Anyway, this particular one doesn't do that. So the whole of the blue bar is connected, the whole of the red bar is connected, and the same here. And just to reiterate, these are rows all the way down here. So a row is connected. Anything that's in A to E is connected, and in F to J is connected. Anyway, that's a breadboard. And the idea is that it's a solderless connection board, if you like, to connect different components together. Okay, what have we got next? So next I want to look for jumper wires. So we've got some jumper wires here, or jumper leads these are called. What else have we've got another set in here as well. I'll just get them. I'm struggling to get them out here. There's quite a lot of stuff in this pack. Okay, so we've got jumper wires. So jumper wires, they jump from various different positions on the board, and they sort of aid that, of course. So I'll just zoom in and I'll just give you a demonstration. Let's zoom in here. So we've got a breadboard, and now let's say we want to connect a pin on here to something else. So let's go here, we'll push this in. Now you'd push it in all the way usually, but it can sometimes be difficult to pull it back out again, which is why I'm not going the whole hog. But let's say we wanted to connect this to, I don't know, what have we got hanging around here? So just to give you an illustration, or actually an example of how we could do this, I'm going to get an LED. Come on, get out here. I'm going to get an LED. I'm going to put an LED in here. Remember that the rows are separate, so we've got the anode and the cathode. I'll go into this in more depth later, by the way. And we've got these two here, so these are male to male jumper wires. Then we're going to go, we'll use the black for ground, so we'll put that in there in position number 3, and we'll put the other one in position number 2. So we've stuffed them in there like that, and then we'll go ground. I can't remember which is ground now, so ground is number 51. So we'll go like that, yeah. Oops. There we go. So that's a really simple connection. So what's happening is that we've got somewhere on MicroPython, the Pico, we've got a ground and a GPIO pin, and we've gone straight over, we've jumped over if you like, to this row here. And in this row here we've got one which is the cathode and one which is the anode. And that's basically how it works. And you can do this with all sorts of components and stuff. So there are some male to male jumper leads. We've got some male to female. And male to female, what could we use a male to female for? So if you've got a sensor that has male pins, you could put the 3 in there, like this. I can get it in. Put the 3 in there, and then the corresponding ends you could plug into the breadboard wherever it needs to go, like that. And like I said, you can pull these apart. Not that I'm going to at the moment. Okay, so they are your jumper leads. You can also get these ones as well, which I think are quite good. They're a lot tidier. And these ones are really simple. They're basically if I just can get one there, I've dropped one in the wrong container. So these are just solid core wires, whereas these are a multi-core, which is basically how they're composed inside. This is one solid wire. I don't know if you can see that. Anyway, so this is the same idea. You can go from ground. Let's do this properly. So we'll go there to there. So I don't know if you can see there. We've gone from ground. Then we've jumped over to here. So ground now goes over here, and then we want another one. Let's say the green one. We want the green one to go from the anode to that, well, GPIO 1. It is on here now. And it's just like that. So we've gone from ground to ground, and we've gone from GPIO 1 to the anode of the LED, presumably in order to light it. So that's how you can use the breadboard and the jumper wires, or jumper leads. Okay, what else? Let me just pull these back out. These bend as well, so you can shorten or lengthen them slightly if you need to. So these are all as part of the package that Maker Fabs has given to me. So that's quite good. Got little ones there and longer ones as well. Okay, so we've covered that. What's next? So we have buttons. Got buttons here, so we should have 2 types of button. Yeah. So we've got these little things here which are momentary buttons, so you can click them like that. These are the sorts of ones that you'd get in joysticks, joypads and stuff. You know, like PlayStation ones. You know, when you get the little circular button, underneath the circular button it actually presses one of these. Yeah, as I thought, we've got a different type of switch as well. You've got a switch which holds its position, so it holds its state, so it's either on or it's off, and it has its pins as well, which we'll discuss another time. So we've got those ones as well. what would we call those? Latching, that's what we'd call them. So we've got some momentary switches, which I think are also called tactile or tactile or something, and we've got latching switches. What else have we got? We have LEDs, which I just shown you just a minute ago. Looks like we've got different coloured ones, so we've got red, blue, green, yellow LEDs. They have an anode and a cathode, and of course the purpose is to light up as an indicator. Okay, so we've got LEDs. What else? We've got resistors. Resistors are here, and you get these. So resistors have little codes on, and the code is in the form of a well, it's basically stripes of colour, and each stripe represents a colour, and by reading the colours you can find out the resistance in ohms of the resistor. And you need resistors basically to limit the amount of current that flows through a circuit. So here's a good example actually. So if we were to connect this directly to 5 volts, an LED, it would most likely burn it out. But if we added a resistor in place with it in series, so we had a battery, an LED and then a resistor, the resistor would limit the current, and therefore presumably or hopefully it would not burn the LED out. Again, we'd have to go into more depth with this. I'd have to explain it in more depth, but generally speaking that's that. So what else have we got here? So we've got a piezoelectric buzzer, and it just makes a sound. So it's the sort of thing you'd have when, I don't know, I guess you could mock a sort of burglar alarm or something like that, when a circuit is powered, or when this is powered, it makes a sound to alert you of something. So yeah, it's really simple to use. You just literally power it. When it's powered it makes a noise, and when it doesn't have power it doesn't make a noise. Okay, so we've got that. This is called a potentiometer, or some people call it a variable resistor. And again, we'd have to go into this in a bit more depth in another video. But you can do various different things with this. But if we just say for now that its purpose is to, well, it's like a resistor, but it's variable. So you might not want 100% of resistance. You might want half of the resistance for whatever reason. And this allows us to do that. So that's a variable resistor or a potentiometer. What else have we got in here? So, oh, this is quite a good one. Can't wait to try this one out. So this is a PIR. So a PIR is something you get in a lot of modern motion detectors. Again, for like burglar alarm sorts of things. And this is a sensor. So you can see that it looks quite complex. It's got its own PCB. So yeah, like I said, this is a sensor. It's not a regular component like an LED or a resistor or a switch. It's more complicated than that. So the sensor reports on changes in the environment, basically. It reports it back to the microcontroller for the microcontroller to then know about it and do something about it. And of course, in this case, you could wire it up and it could tell you if somebody is close to it. Therefore implying that, there could be unauthorized access in the building or whatever. Okay, so that's that. You've got some things to adjust it. You've got some other components like capacitors, but you don't need to know about that at the moment. And you've got some inputs and outputs. So there are 3 pins. It's really quite simple, but more on that at another time. What else have we got here? We've got, there's, what's that in there? It looks like there's 2 things in there. I'll have to open this up. Just a minute. Okay, I have it out. So it's not actually 2 items. Well, it is, but you could consider it as one. So as you have probably already guessed, this is a output device. This is to output some text to you. This has a special backing on it, which is a converter that makes it easier to use, basically. So I don't know if you remember from a few videos ago, I said there are two protocols, communication protocols, SPI and I2C, or some people call it I2C. So from what I remember, this used to be this was SPI, but it's now got a board on it which converts it to either or. It's not something I know about. I've never used this particular board before. There's another one I've used, but presumably it does the same job. So yeah, you have this little converter board. We could actually Google that there and find out more about it. Suffice to say though, it's a converter board, and the purpose is to make it easier to use. Eventually you'll be able to output to this to say hello and whatever else. You know, output the state of something. Okay, so we've got that too. Don't need to look at that anymore. We've also got this added in as well. Let's see what this is. WS2812. LEDs, they are LEDs. And I think they might be RGB ones as well, which means that they can display a whole spectrum of light. Yeah, these are LEDs. The next thing in the book is this idea of resistor color codes. You don't need to worry about this too much, because when you buy resistors you have to specify the resistance that you want. So say you were going to buy some 1 kilo ohm resistors, you would search on a website for 1 kilo ohm resistors. You would never be expected to say I want orange, orange, brown. It doesn't work that way. So it's not the end of the world if you don't understand this, or if you don't know them off by heart. So when it does matter is when you've got bundles of resistors with no labels on them. What I usually do when I buy resistors, I usually write on how many ohms they are here. Of course, resistance is measured in ohms, so I'd write how many ohms it's worth. Okay, but in this case it doesn't say that, so we would need to work it out. When you get your resistors, you'll notice that they either have a 4-band or a 5-band, well usually anyway, 4 or a 5-band colour coding system. In the book there are 4 bands, and if we just go through these and do some examples. So in this one here, it gives an example. It says the first band is orange, the second band is orange, and then this band, the third band, is brown, and then it's got this one here which is gold. So if we just take this one for example, say we've got a resistor which is orange, orange, brown, we can find out how many ohms of resistance this could offer. So the first one, if you look at orange here, means 3. The second one is 3. So you don't add them together, you you assume that they're next to each other in a number. So like 3 and a 3 is 33. So 33, because it's 3 and a 3, and then this is the multiplier. But you don't have to think of it as a multiplier, you can think of it as adding zeros. So if it's black, if the multiplier is black, you add no zeros. If it's brown, you add 1 0. So if it was orange, orange, black, you would say 3, 3, which is 33, and no zeros, which is 33. If you, let's say it was a brown one, we had 3 and a 3, which is 33, and with 1 0. So 3, 3 and 1 0 is 330, which is 330 ohms. If we carry on, let's say we have orange, orange, and red, that would be 3, 3, and then 2 zeros. 3, 3, 0, 0, which is 3,300 ohms, or you would just say 3.3 kilo ohms. And likewise it goes on. So if we were to do orange, orange, or in fact we could do a different colour, we could do brown, brown, we could do brown, brown, and then yellow. So that would be 1, 1, 0, 0, 0, 0, which is 110,000 ohms, if I've just calculated that correctly. And it pretty much goes on like that. Tolerance, again, you don't really need to worry about tolerance, especially as a beginner, because the only time you'd really be interested in tolerance is if you're doing some sort of specialist project, which I don't think we will be in this series. Anyway, that's how that works. So there's something I'm going to tell you about this colour coding, which it doesn't seem to mention in the book, but it's something that I feel is quite important. I don't think people should get overly hung up on this colour coding thing, for the simple reason is that it just doesn't always work. So the first thing is that in here it shows you a 4-band resistor, and that would be fine if all resistors had 4 bands, but they don't. Some resistors have 5 bands, some have 6 bands, and some don't have any bands. Some of them will actually have written on them a number, which is great, but majority are like this, where there are bands. The second problem with this is that it's not always clear which is the first band. So if I just get this 10k one to start with, let's say we just give it a quick read. So there we've got brown, black, black, red, brown. So to start with, it's a 5-band one, not a 4-band one, like the book shows. It's 5-band. But you know, okay, the principle is the same. So we've got brown, which is 1, black, which is 0, black, which is 0. So that's 100. And then we have the multiplier of 2. So 1, 0, 0, and 2 more zeros, which is 10k, 10,000, 10k. And then we've got a tolerance of brown, which is 1%. So we've got a 10k resistor with 1% tolerance. But as a beginner, how would you know that that is the first band? You wouldn't. So if you turn it around, you might read this and you might think, oh, okay, easy. 1, and then we've got red. So we've got 1, 2, then we've got black. 1, 2, 0, with a tolerance of 0. Sorry, not a tolerance, a multiplier of 0. Okay, so that's 120 ohms, with a tolerance of brown, which is 1. Oh, 120 ohm resistor. But it's not, and you wouldn't really know that. So the problem with this colour coding is that you don't know which is the start band, and that's a real pain. More often than not, if you do it backwards, it doesn't make any sense. Like the resistance is something crazy that just doesn't sound right. But as a beginner, you wouldn't necessarily know that. And when I first started doing this, I didn't know that. I would just read any side and not click that there's a way to know the first and last bands, which, to be honest, even now, I don't really know how you know which is the first band. I just read both if I need to, and determine which is correct by how crazy the number is. I mean, if you get something like 1.22 million, you know, something like that, it's not going to be right, probably not. Whereas if you get something like 1,000 exactly, chances are that it will be right. Anyway, ultimately, this is what to do. Get a multimeter, I'll just put it on. So we'll go from there to there, and it says here 9.85 kilo ohms, which we would call that 10k. Now if I do this one, this will be 300 and something. Let's have a look. This one is 326 ohms. Okay, so, but basically don't get too hung up on this. Even if you don't learn it, it's not the end of the world. Like I said before, when you go to buy resistors, you go on eBay or whatever, you're going to type in 1k resistor or 10k or something like that, usually. And when it arrives, you know, you can just get the orange band, yellow band, and just write on it however ohmed it is. It's really simple. But for reasons to do with theory, they want you to know this. Anyway, so there you go. That's today's video done, and it looks like next time will be this, your first physical computing program to do with LEDs. So there you go. Thank you for watching. I hope you've liked the video. I'll put the link in the description for this kit. It really is quite good. I don't know how much it is right now, but when I was looking at their website, it was pretty good value. Okay, thanks for watching. Bye.